Let's take a look at some purification methods. This is Dr. B, and we'll look at simple and complex methods of separating mixtures. When scientists encounter mixtures, they almost always want to separate them so they can understand them. Maybe it's as simple as a pure oil mixed in with a pure water. However, it's heterogeneous, so all we have to do for an oil-water mixture is do layer separation. This is sometimes known as separatory funnel separation, since that's the name of that device there. It requires the two liquids to be insoluble or, same term, immiscible. Fine. If you have an insoluble solid in a liquid, like for example coffee grounds in water, just filter them out. Sand in water would do the same thing. This is known as filtration, and in this case this would be gravity filtration for insoluble solids in liquids. If you have a soluble solid in the liquid, you still can separate it out, but you better get it to the point where it precipitates. This is typically done by reducing the amount of solvent until it crashes out. If you've ever made rock candy, that should be pretty evident. Or if you've ever just watched salt water evaporate, the salt sort of crystallizes out with time. This is known as crystallization. Still in use, wonderful techniques. Two liquids, both soluble in each other. How do you separate them? Well, they're likely to have different boiling points, so we separate them by distillation. Works best if the boiling points are relatively low. If they're not, if it's like motor oil or honey, you still got some options. Or if that liquid decomposes when it goes to a high temperature, like sugar. The trick there is to apply a vacuum, which goes right there. And I think it would help if we identified each part of this distillation apparatus. We begin with number one, which is the pot. You put your mixture in there. Typically you spin it. Part number two would be the distillation column, which is particularly short because this is known as a short path distillation apparatus. Position number three has your thermometer in it, so you can conveniently record the boiling point, rendering this not only a separation technique, but also an identification technique, since you will get a boiling point as you go, if it's efficient enough. Water goes in, position 6, and water goes out, position 7. And this is simply an exterior jacket known as a condenser, since this renders the inner tube nice and cool so that it can condense, turn that boiled gas back into a liquid. Position 5 here goes right to the interior tube, so you can apply a vacuum, which is basically pulling gases out as they form. Don't forget it condensed already, so we should be okay, and you won't lose your stuff. And then it goes into position, what is that? 8, which is simply your receiving flask. That is distillation. If you really got a tough separation, say 1 degree difference in boiling point, use this thing. It's not a vacuum distillation apparatus. This is known as a spinning band distillation apparatus. The idea here is to get awesome separation by using a huge distillation column. Not a couple inches here, but rather a couple of feet. And also stick what looks to be like window screen in there and spin it inside there to give you massive effective surface area, rendering your separations very efficient. If you have something like ink in water or ink in a solvent, just put them on a stationary phase like a piece of paper, let them run up, and each dissolved substance should have a different retention, adhesion to that stationary phase, which in this case is paper, and this is known as paper chromatography. In practice, it's pretty streaky and not very efficient. We can bring it up a notch by using silica gel rather than paper and other different types of stationary phases. We call this thin layer chromatography. That's what scientists use for separating out small amounts of solids. If we want to separate gases, we can do so by the same idea. Gases will also adhere to a stationary phase. So take a liquid, boil it, run it through a tube where you have a lot, like a copper tube where there's lots of stationary phase, and you should get great separation due to the adhesion of the gas to that stationary phase. So this is not liquid chromatography, this is gas chromatography. And finally, you can also do thin layer chromatography, but bring it up to a third dimension. Instead of running it up a piece of paper, run it through a tube. And usually these devices are known as high-performance liquid chromatography or HPLC devices. And the idea is there's your tube right there. Rather than running it up a piece of paper, you push it through a tube. That's your stationary phase. Things stick to varying amounts. You normally get some sort of a viewpoint here through a screen, and the stuff drips out the other end. You collect it, and this is high-performance liquid chromatography. These are some purification methods.